No, one of them was sneaker. I'm like, oh. Lead by example. Unless they're in class. Right, I know.
Oh, that was the wrong way. Howdy.
Hello.
Yes.
Do you have assigned seats?
Yes.
Where do I sit?
That way you don't have to sit in a seat that somebody just sat at. You sit. You.
Anna.
Anna. Right there. Dark blue. I knew you were Anna.
No, she's in insurance business. I mean, when she's remote, so you don't like actually do it.
Oh, okay.
Yeah.
Okay.
Like, I'm okay. I can do it now. I just don't want to. Hybrid is good. I like that. Yeah. I just had this in my kidneys, so you know that happens a lot. Yeah. All the arrows. I know.
Okay.
I wrote me for my desk. Me. Okay. As long as I know where I'm at. Did you see my outfit coming? Check out my shoes. It don't even matter. I left the house today. I was like, I do cute.
Howdy. Were you able to do the test all right yesterday and everything? Okay, but you were able to start it and answer. Okay. Because I know I saw you look like you're having troubles in Zoom. I was like, just wanted to make sure. Okay, cool. All right. Hey, we have everybody. Look at this. We're ready to go. All right, VZPNEO. Join that. You will want to join that for today. There will be stuff to interact with. There'll be like flashing colors, buttons. Actually, there's a graphing one where it'd be helpful for you to actually have the graphing grid that you can then use. Code's over there, so I'm going to go ahead and shut this down. All right, here it is. This first one is a doozy, all right? And my first hour, there was 12 people there. 2 of them got this right, okay? It's question 59 of I think it was the spring 2016 ACT or whatever. And so this is a question you would want to get right if you're looking to get that really high 35, 36 score on the ACT. I'll give you a minute like you would have on the ACT to try this out and see what you think your answer is. Man, it goes by quick. Let's see. Let's see how we doing here. All right, so far no one has the correct answer, which is okay. Because again, this is a really tough one. Let's go over how to do it rather than have you sit and struggle with this so any more than we are already. Okay. How to do this problem requires on you having a pretty good foundation of how quadratic functions work. How many solutions do you normally have in a quadratic function? Like you get, let's just look at a simple one. X squared plus 4x minus 3. Oh, no, that's not, that won't work. 4x plus 2x minus 3 equals 0. All right, how do we solve that? Well, we could factor it. We could quadratic formula, right? So maybe this one would be what? X plus 3x minus 1. I think that works out right. 3 times -1 is -3. 3 plus -1 is +2. Okay? And so that I would have two solutions, -3 and +1. Right? But for this one, it says that there is only one solution, -3. How? How is that possible? That would mean that both of these have to be x plus 3. Right? That's the only way that could happen. And then you just have to multiply this out. X times x is x squared. X times 3 is 3x. Don't you know? 3 times x is 3x. 3 times 3 is 9. So x squared plus 6x plus 9. And it says, what is the value of m? Right there, right? That's it. Sure. See? It gets doable under a minute, but it requires you to know, what the solution form for a quadratic equation even looks like, right? Yeah, that's a tricky one. But again, there's a reason why it's number 59. But hopefully now this is one we could get, right? We know that quadratic functions can either have two solutions like this, one solution like that, or no solutions, in which case, like, it's not factorable, right? And the quadratic never crosses the x-axis, right? Like, it could be above the x-axis, opening up, or below the x-axis, opening down, right? So it never actually goes through the x-axis. Did I just say gibberish at you, or you're like, no, that makes sense? A little bit of both? Okay, all right, okay. I'm going to clear this and move on unless one of you people says no. Oh, you need something, right? I got you. I got you, buddy. Buddy, old pal, old friend. No problem. That's what they pay me for. So, England, a borrowing. Okay. Here's what we're doing today. All right, so today's the first time we've started actually doing a lecture under this new format. So let's make sure we understand how the format of this new schedule works, because I think there is some misunderstanding. In this schedule, which actually I think I have it. Do I have it? Can I show it? Is that something I'm capable of? No, I closed out of the tab. Okay, in this schedule, I got it right here, right? You're supposed to have 40 minutes in class and then 50 minutes on your own. We're going to see how that's going to work for us using WebAssign. All right, so I'm going to lecture over, over this, and then I'm going to kick this out for you to do through WebAssign. Okay, so in WebAssign, right? Home. Ebook, right? No, do I want the ebook? I don't want the ebook. I need student view. That's what I need. All right, so in WebAssign, you go to resources, You open your textbook. We're in chapter 2 now, and we're in 2.1. So, and you got these videos over here. I'm going to do these first 2 videos, which are, this is the big one. The rest of these videos, they're all really short. I know it looks like a lot, but each of them is like 4 minutes. So in total, it ends up being like, this one's just a minute. This one's a minute too. This one's 3 minutes. So I know it looks like a lot for you to watch, but each of these are super small. So it should take you like 15, 20 minutes to watch through all of these. Okay. And then the other to do at home thing that you have is, of course, the assignment 2.1, which is, I think, 11 questions, 10 questions. 11. And none of them are really that bad, to be honest. The first 2 are just graphing. You just graph this, and then you say which one of these is the graph. So, and then Monday, I won't be here. I'll have a sub, okay? And you'll do the whole thing on your own. So for Monday, what I would recommend you do, you get into class, the first thing that you're going to want to do is go to 2.2, in this case, in your ebook, 2.2, and read through this. And then you'll watch the videos, not for 2.1, but you'll watch them for 2.2. And then you'll have a homework assignment, which again is like 10 to 12 questions. Wednesday, we're going to have a work day just to go over and see how we did with this model, or if that model is absolute garbage. Okay, but we're going to do a trial run of 2 lessons to see if that is going to work. Because to be honest, if that doesn't work, then the only other option is to cut out material. And if your goal is to take this as a pre-calculus class to get you ready for AP Calc, cutting out material is rough. That is going to make it difficult for you to get the score on the AP Calc test that you'll want. Because they just assume that you know all of pre-calculus going into AP Calculus. The AP Calc test assumes if they give you a problem with calculus that requires you to do pre-calc, they won't even, they'll be like, oh, everyone remembers all of pre-calc. I'm not even gonna they'll be very skippy about that. Okay, that's enough of the administrative stuff. Now let's get to the notes. First note that we had to talk about is how to graph quadratic functions. I have 2 definitions here for you to write down if you so choose. You don't have to write this down, or you can write this as much as you want. But the idea here is chapter 2, we're going to solve polynomial functions and do like the properties of polynomial functions. What a polynomial function is an equation that can be written in that form where every variable has an integer power and some real coefficient. So for example, x to the 5th plus 3x to the 4th minus x squared plus pi. That's a polynomial function because every x has an integer power, 5, 4, 2, or 0, and you have only real numbers. The square root of 4x, square root of x plus 4x is not a polynomial because a square root is what raised to the 1/2 power, so it's not an integer. The cosine of x squared is not a polynomial function because again, it has a trig function in there, and that is not allowed in polynomials. All that's allowed in polynomials are real numbers, x's, and powers that are integers. A quadratic function, now really, to be honest, you probably don't have to write down the second one at all, hopefully, is a function that could be written in the form ax squared plus bx plus c, where the highest power is 2. and a cannot equal 0. Are you ready? You ready for me to throw a fastball at you? Some heat? Why in the definition of quadratic function does it say a can't equal 0? Why does that have to be there? What would happen if a was 0? That's right. Nice job, Ty. That's your real name, right? If a was 0, 0x squared is 0. Then this just becomes bx plus c, which is slope-intercept, right? With b as your slope and c is your y-intercept. Fancy? Fancy. Everyone thinks that's great. Do, 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 do. All right. I will say this lecture, I feel like, is not going to serve you as much as I hoped it would. I prepped this lecture with the idea that you did completing the square in Honors Algebra 2, and your first hour friends told me that they did not do that. And so I was going over something like it was review, when I think it's really new material. So that might be a little sketchy. Do, 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 do. Almost getting done, getting close to done, right? I like that the leaves are changing colors. I don't like that it got up to 90 degrees again. That didn't need to happen. It could have just stayed, highs of 70s and 80s. That'd be great. I think it's supposed to get back to that. What's the weather going to be? Speak Kansas weather. Is it 80s today? See, 88, that's too high. That's not nice. Doesn't need to happen in October. We need this. This is okay. It looks like next week is going to be just fine. But this, I feel like it should be raining more. I don't know. I feel like it hasn't rained in a while. All right, clear this and move on. Cool. All right, so here is how much do you remember? I have two functions here. You need to graph them on the little slide here. Each of these functions have two transformations from the parent function x squared. Okay, so here's your parent function. Actually, I'm not going to graph it. No, I'm going to. No, I'm going to. It never hurts to give more information. Okay, that's x squared, right? That's the parent function for a parabola. You need to graph g and h and identify the two transformations of each. I'll give you 3 minutes. All right, let's see how we're doing here. That looks okay. It's okay. Okay. Okay, okay. All right, looks like we've gotten through the most one for most part. Okay, so let's go over it. And I think what I'd like to do is let's just do this randomly. 1, 2, 3, 4, 5, 6. I'll do it. 1, 2, 3, tie. That's you. Tie. All right. Start for this first one. What's that negative do? Upside down. So reflect over the x. Reflect over x. What does the +1 do?
That's what the y-intercept.
Goes. Yeah, you're right. It's the y-intercept functionally for this problem. Yes. Yeah. Yeah, I'm picking out what you put down. The transformation we said technically would be it translates up 1. So it should look like that. Okay, great. And then we'll just go left to right then. Anna, what's the +2 do? Yay! And I'm glad to see that. I know some people didn't quite get to it in time, but nobody moved it to the right. That's good. And what's the -3 do? Yay! So that looked like this, left 2, down 3. So now this is the vertex, and it'll be like this. So you'll notice that since this one, as Ty said, opens down, this point right there is the max. But since this one opened up, this point right there is the minimum. So finding max and mids, I know you're going to watch a video over it, but long and short of that video is if it opens down, the vertex is the maximum. If it opens up, the vertex is the minimum. And then this one wouldn't have a minimum, right? It just goes down to a negative infinity. And this one doesn't have a maximum. It just goes up to a positive infinity. Okay. All right. So now here's the meaty part of the lesson. And I guess this might be new for you. They might not have covered this in algebra 2. I have to talk to her. Well, I can't talk to her. She doesn't even teach here anymore. So every quadratic function could be written in ax squared plus bx plus c form, but it can also be written in what's called standard form, a quantity x minus h squared plus k. And in that form, it's actually pretty useful for finding, pulling information from the graph. One is the biggest thing that this helps you compared to the quadratic form is, or compared to the ax squared plus bx plus c form, is that h right there gives you the line of symmetry. Because you'll notice every parabola is symmetric about its center, right? The right and the left half look the same. So that vertical line, x equals h, will pass through the center of the parabola, splitting it in half. The vertex is also really easy to find. It's just hk. So if it's written in standard form, you can tell me the vertex really quickly by just pulling out those two numbers, h and k. And again, like we said earlier, if A is positive, that means it's going to open up. And if A is negative, that means it opens down. All right. However, on the ACT and, in life, they won't always give you the quadratic function in standard form. they may give it to you at ax squared plus bx plus c. If they do, to find the vertex, you have two options. One is to complete the square. The other is to use this formula. H will be negative b divided by 2a. And then I didn't write it down, but then k will equal f of h. So if it's not written in standard form, you still can find the values of h and k. H is negative b divided by 2a, and k is f of h. I will be honest, using those two formulas at the bottom of this slide is the easiest way to find the vertex. The other option, completing the square, is a lot more difficult. However, it is a skill that you need to know how to do because it's used in AP Calc to complete the square. Now, if you say I'm not going to take AP Calc, I'm taking college algebra, probably stats next year or whatever, then you could probably get away with just the formulas at the bottom. But if not, you should really master, or at least try to practice, completing the square. Plus, it's fun. That's a lie. It's not fun. It's not terrible, but it's not the most fun math I've ever done. All right, how we doing? Good to move on? Teresa, you need a little bit more time? Okay, that's all right. I have a French press, which I use to make coffee, cold brew coffee, right? You just grind up your coffee beans, you put it in, you pour water into it, you let it sit in the fridge for, a day or two or whatever. Press it down. It's so hard to clean those things. I don't like it. I mean, I had it and I was using it. I was doing a good tempo with using it, cleaning it immediately. So I always had cold brew. And then I got a little lazy, and now it's just like, it's so much work to clean it every time. Because you don't want to just rinse it out and pour it all down the drain. Because your coffee grounds really shouldn't go in the drain. They need to go in the trash. So you have to scoop all this stuff out. And it always clings to the bottom. Get a paper towel, you wipe that out, and then you have to go and wash it. And you'll still get some coffee grounds in the drain, probably, but hopefully not too much to cause you any issues. It's the whole thing. It's the whole thing. They need a self-cleaning French press. That's what they need. That makes some money. I don't know how it would work mechanically. Well, maybe could the bottom, because it has to also be sealed proof. I don't know. One day, if I walk in here when I'm supposed to, I don't walk in here when I'm supposed to be, you'll know it's because, he figured out how to make a self-cleaning French press. And now he's rich, so he doesn't need to come in anymore. Okay? All right, we're going to do an example. This one's really quick. So for this problem, A would be 1. H would be, okay, this is going to be the most missed thing on the test, quiz, whatever, homework. H is -2, not +2. Right? If you look at your formula in your notes that you just wrote down, it says -h squared. So if you have a plus here, the only way that plus gets there is if h is negative, because minus and negative makes a positive. And then, draw, and then k is -3. So then, once you know those three things, you're able to answer a lot of questions that they could ask you about this on the homework, on a quiz or test, or on the ACT. We could say that the since A is greater than 0, this opens up. We could say that x equals -2 is our line of symmetry. we can say that -2, -3 is our vertex. And again, since this opens up, what that means is that this has a -2, -3 is the minimum. And it has no maximum. I mean, there's more stuff we could say. We could say like it's decreasing from -infinity to -2, increasing from -2 to infinity. And all of that information comes from A, H, and K. So knowing how to recognize this form and pull out those three numbers to then tell me information about the graph is the goal. And when you're taking the ACT and you have a minute to do a problem, they're going to give you a question like this and ask you one of these and assume you're not going to reach for your calculator because that will probably end up taking more time than a minute. All right, so that's the easy example. You ready for the hard example? Here's the heat. Look at this. I want to find all of that information, A, H, and K, and everything that implies from this one. Here's the problem. This is not written in standard form. So how do I get this into standard form? Here's what you need to do. You have to complete the square, or use your formulas. All right. Let's do this one first. If we complete the square, here's the following 6 steps in order to do it correctly. First step is you need to factor ax squared plus bx. Just that part, okay? So that if I factor those, they have in common a 2 for A and B. And we only don't need to factor out the x, just the coefficient. Okay. So I look at my first 2 terms. If they have any numbers that can divide into both of their coefficients, I'm going to pull that out. For ours, 2 and 8 are both divisible by 2. So I pull the 2 out. That leaves me with 1x squared plus 4x. Okay. All right, this is the weird step. This is the next thing that always messes people up. The next thing you need to do is add plus b divided by 2 squared and minus b divided by 2 squared. Okay, so if I do that, and our problem b is 4 now. So 4 divided by 2 is 2, squared is 4. So I'm going to do 2x squared plus 4x plus 4 minus 4 plus 7. All right, so again, how did this get here? Here's how this gets here. The number 4 I get from doing this little arithmetic right here. I take my b value, 4, I plug it in. 4 divided by 2 is 2, squared is 4. That then goes into my problem right here as plus 4 minus 4. We know that doesn't change the solution because what is 4 minus 4 really? 0. And adding 0 doesn't change your number, right? 10 plus 0 is still 10. So we know that doing this isn't going to change my solution. And by doing this, we create a situation where we could do our next step here and factor this. This is now a perfect square. Its factors, what multiplies to be 4 and adds to be 4? What two numbers? And? Not -2, but 2 and, they're both +2, right? 2 times 2 would give us +4, and then +2 plus +2 gives us +4x. So we end up with this, a perfect square. That's the goal, which is why we call this method completing the square. It will make a perfect square for us to factor. Okay? And now you'll look, this is actually starting to look really close to standard form. The only thing that's really messing us up is this -4, right? That's not supposed to be there. So how I get rid of that is I'm going to now distribute my 2 to get 2x plus 2 squared minus 8 plus 7. Again, does everyone see where the -8 came from? By distributing the 2 into this parentheses. 2 goes in front of the x squared plus 2 squared, but it also goes to the -4. And then last step, -8 plus 7 is really -1. And now that is standard form, where a is 2, h is -2, and k is -1. And now I can use that to identify anything that they'd want to ask. They could ask me, well, what's the vertex? -2, -1. Does it open up or down? Where does the line of symmetry go? It would go through -2, right? I could answer all that question. Since it opens up, that means the vertex is your minimum point. Okay. Last thing we're putting into notes today is the second way you could have solved this problem. So I said you could complete the square or use the formulas. If we use the formulas, you should note that for our problem, A is 2, B is 8, and C is 7, right? A, B, C. So if we use our formula, H is equal to -B divided by 2A. So that would be -8 divided by 2 times 2. Or -8/4, which is -2. Woo. See that? K is f of h. So I'm going to plug in -2 into this problem. So I get 2 times -2 squared plus 8 times -2 plus 7. And I will save you the work. That's -1. And so now what you could do, it's a little unethical, whatever, but you now know what AH and K is. You could write your equation in standard form. 2x plus 2 squared minus 1. So again, if you could probably tell that number 2 is the easier way to do this, right? I'm showing you number 1 because this is something that you will need to be able to do for AP Calc. If you don't plan on taking AP Calc, doing number 2 is fine. All right. So again, that's the end of the lecture for today. We have gone over the hard part, I think, of the lesson. The rest you need to watch on the old website, watch those videos, read the textbook. But I will be honest, if you try the homework first, you might just be able to do the homework without doing that because it is stuff you have seen before in Algebra 2. So you might just read the textbook and watch the videos as needed. Monday, you'll come in, you'll just be working at WebAssign, reading the textbook, watching the videos, doing the assignment. Wednesday will be a work day where we can kind of have a little dialogue on whether or not that model did not work for you or it's just fine. All right. Bye, everybody. I'll see you Wednesday, forever from now. You won't even remember what I look like. You're like, what? Who is Mr. Link? I don't even know.
What are they doing out there?
What's that?
What are they doing out there?
I think they're gonna make a fence. Yep. Around E building a little bit. Yeah. See ya.